Hey everyone, Mr. Fransky here. Today we're going to be talking about 1.4. This section is about building functions from other functions. So students will be able today to add, subtract, multiply, and divide function values. So let's take a look at what we've got for vocabulary. Function, product, quotient, sum, and difference. These are probably words you've heard before, but we'll be using them in a more formal way with our functions here today. So first, let's just do a little bit of work on function notation. So if we have f of x is 2x plus 1 and g of x is x squared, let's have you guys try a few of these. If you want to pause the video and try these, we'll come back in a minute. All right, let's give them a shot. So remember, f of x, wherever this x shows up, that's where we're going to put whatever's in the parentheses. So f of 3 is going to be 2 times 3 plus 1. And I always like to use parentheses. Sometimes it's not necessary, but in this case, especially when we get down to these problems, I like to do it. So 2 times 3 is 6 plus 1 is 7. So that means on the graph of f, the point 37 would be there, right? Because when you plug in x, you get a y value or an f of x value of 7. G of negative 5, once again, I'm going to use parentheses to replace the x. So negative 5 squared. Well, negative 5 times negative 5 is positive 25. So there the parentheses are really important, right? Because if I didn't write them, negative 5 squared here, order of operations would do 5 squared is 25, then make it negative. But that's not what they're asking for, right? They're asking for negative 5 to replace the x, and we square it. F of 0, 2 times 0 plus 1, that's 1. F of a, so that would be 2 times a plus 1, or 2a plus 1. Not too bad. And then f of x plus 3. So this is where it gets kind of interesting, right? So I'm going to replace the x with an x plus 3. So I'll put it in parentheses. X plus 3 plus 1. Now let's make it look a little prettier, so I'll distribute the 2. So we have 2x plus 6 plus 1, which is 2x plus 7. Okay, so that's just in terms of a different x value. So this is like, it would be the function would be shifted left 3. G of x minus 2. Once again, I'm going to replace the x with x minus 2 squared. Now we can leave it there, but remember, if we FOIL this out, we have to do two parts, right? X minus 2, x minus 2. This is not x squared minus 4. So if we expanded this out, it would be x squared minus 4x plus 4. There we go. Cool, not too bad. So doing stuff with functions, this is really the purpose of this video, is just to get the notation down for these four things. So let's just kind of take a look and see what we've got. So f plus g, what this means is you just add f of x plus g of x. Okay, so we'll just do all the notations and then we'll get to some of the examples. So f plus g of x is just f of x plus g of x. F minus g of x is f of x minus g of x. You guys probably guess what these are, right? Fg of x is f of x times g of x. And f over g of x is f of x over g of x. Okay, so for f plus g up here, let's see what we would actually have for this function. So if I add f and g, I would have 2x plus 1 plus x squared. So if we wrote that all as one function, probably write x squared plus 2x plus 1. So that would be f plus g of x. So if we want to try an actual value, if we plug 2 in, well, we can just do it by definition, f of 2 plus g of 2, which is going to be f of 2 is 4 plus 1, that's 5, plus g of 2 is 4, so 5 plus 4 is 9. Or we could take the function right here and just plug in 2. 2 squared is 4, plus 4 is 8, plus 1 is 9. Either way, you get 9. F minus g of negative 1, so that's going to be f of negative 1 minus g of negative 1. So I'll come back to the function here in a second. But f of negative 1 would be negative 2 plus 1 is negative 1. And then minus g of negative 1. Now g of negative 1 is interesting, right? That's negative 1 squared, which is positive 1. So negative 1 minus 1, that's negative 2 altogether. F of x minus g of x, that would be 2x plus 1 minus x squared, right? Or negative x squared plus 2x plus 1. You can write it however you want, right? Fg of 3, that'd be f of 3 times g of 3. So that would be 7 times 9, 63. F over g of 1, so that would be f of 1 over g of 1. And f of 1, let's see here, that would be 2 plus 1 is 3, over g of 1 is 1, that would be 3. Now, some interesting stuff comes up when you start dividing functions, because if you're given something like this, f over g of 0, well, f of 0 is 1, but g of 0 is 0. That doesn't work. This is undefined. So f over g of x is only defined if g of x is not equal to 0. Because if g of x is equal to 0, then we'd be dividing by 0, which isn't okay. So see here, fg of x in this case would be 2x plus 1 times x squared. You can distribute it in, so it'd be what, 2x cubed plus x squared. And then for the division here, we would have 2x plus 1 over x squared. Yeah. All right. I think I've got one slide for you to try, and that's it for this video. Finally, a short video, right? All right, why don't you give these a shot, then we'll try them together. All right, so if we have f plus g of 3, that's going to be f of 3 plus g of 3. So f of 3 is 9, g of 3, 3 plus 1 is 4, square root is 2, so that's 11. Fg of 8, that would be 64, oh boy, times 8 plus 1 is 9, square root of 9 is 3. Let's see here, 3 times 6 is 18, so that's 180, plus 12 more is 192. A little mental math for you there. G over f of 3, well, g of 3 we just did, that's square root of 4 is 2. F of 3 is 3 squared is 9, 2 ninths, best we can do. F plus g of x, well, that would be x squared plus root x plus 1. And we're done. That's all we can really do with that. We can't really simplify that anymore. F over g of x, that would be x squared over root x plus 1. Now, if you're really specific and don't like to leave roots in the bottom, if we multiply by root x plus 1 over root x plus 1, and I wouldn't expect you to rationalize this. For just doing functions like this, you'd be fine. But that would be x squared root x plus 1 over x plus 1. Right, because root x plus 1 times root x plus 1 is just x plus 1. GG of x, let's see, that would be root x plus 1 times root x plus 1, which is root x plus 1 squared, which looks like it should be x plus 1. Now, the tricky thing is, what's the domain? Well, if you graph this on Desmos, it's actually kind of interesting. Put in Desmos root x plus 1 times root x plus 1, and what you'll see is you get the line x plus 1, which would be a line with a slope of 1 and a y-intercept of 1, so it'd be something like that, but it starts at 0. It won't go to the left because the domain here, root x plus 1, is only good. Oh, I did something wrong. It would be down to here. It would go to negative 1. Yep. Because root x plus 1 is only good for bracket negative 1 infinity, right? So the problem here is that because of the way g is defined, even though I'm multiplying them together and it looks like we're squaring it, this is the original function I actually have to consider. So it's only going to be good from negative 1 to infinity. Kind of interesting. Graph that on Desmos. It's kind of cool to take a look at. And that is all I've got for you. So, love you guys. That's why I'm here, and I will see you in the next video.